This is a video series on Timesys TimeStorm IDE. Let's take a closer look how TimeStorm assists with profiling through instrumentation. Let's create a new project of a C project type, and using TimeStorm Wizard, we're going to select one of the samples that Timesys provides specifically for profiling with or through instrumentation using Gprof. We just selected the Gprof example. We're going to give it a name. Profiling instrumentation Gprof. And in the next step, we're going to select the toolchain with which we want to compile the project. As usual, we are selecting one of the available toolchains, in this case a Yocto SDK. That's going to help us set up a project in TimeStorm. At this point, we can expand the project and build it using the context menu. Once the compilation completes, we can see clearly that we have an ARM executable which we can run or execute on a target platform. You can see in project properties what it means to set up a project for profiling through instrumentation. Under project settings, we can see the two flags PG and G3. We can select debugging option, and you can clearly see the checkbox that's selected. By selecting this flag, we can really profile through instrumentation any of our applications that are developed with TimeStorm. Using the context menu, we are selecting TimeStorm profiling tools and Gprof to launch the profiling configuration screen. In this screen, we can see that there is an entry already for our program, and we can specify additional arguments for the program and other options, including the target. From the drop-down menu, we are selecting the target that we've defined, and we can apply the changes and click the profile button. TimeStorm launches the application on a target and collects the profile data. You can see in the output that our application, the sample application, expects a parameter number of iterations. So let's redo our profiling by specifying this time a number of iterations for the test run. So we are back in the TimeStorm profiling tools configuration menu, and under arguments we're going to specify 1000 iterations. With that, let's relaunch the profiling. Again, TimeStorm launches the application on a target and collects the profile data. Then it copies the profile data to our host machine where TimeStorm is running, and under debug directory source, we're going to see a file called gmon.out. That's our profile data. We can now double click on the gmon.out and launch the gmon file viewer. That's the viewer of the profile for our application. Let me increase the size of the window. You can see under summary, application name, and you can also see samples, number of calls, and time that is spent in a specific function in our program on the CPU. You can clearly see that 80% of our time is spent in a B function. Specifically, 56% is spent in at one of the instructions. Let's double click on this. TimeStorm opens up the source code itself and highlights the line where this 56% is being really spent. The profile information is available for all lines in this code which actually get to run on our target. And you can clearly see which while loops or which instructions in our code consume most of the CPU time, allowing us to identify all bottlenecks that unnecessarily consume CPU time. Now let's take another example of a C application, a multi-threaded C application, which represents an application that's developed with TimeStorm. So we're going to leverage one of the example application code that's in TimeStorm. We're going to select the SDK for it, and we're going to very quickly set it up in TimeStorm IDE. Now, right mouse click, we can take a look at the properties of the project. You can see that under Settings, Debug, I'm selecting the Generate Gprof information flag. And now I can compile the project. First, let me clean the project because it may have, if I run another build with a different toolchain, it may have some of the object files in there. So I've cleaned the project, and at this point I can go ahead and build the project, which should result in an executable, ARM executable, that I can run right now on a target. You can see clearly that I do not have a gmon.out file yet. So in the next step, let's launch a Gprof profiling session, and we do that by creating a Gprof configuration, selecting the target just like in the previous example, and launching the profile session. You can see the gmon.out file being generated and copied over to TimeStorm. I double click on it. That launches the Gprof analysis view, and you can clearly see that I have a multithreaded.c entry here with thread func, which is a function executed by each of the threads, which shows me that profile information from some of the threads at least got captured in this session. And I have direct connection to the source code as well. But if you look at the profiled information, you can see that there is libfuncs.s, which means that most of the time the CPU has spent on executing functions that have been called by my application. Those functions are implemented inside a library which does not contain any of the profiled symbols. Hence, I cannot expand and take a closer look at how those libraries are being used. So in the end, Gprof is one of the utilities that's nice to have in your toolbox, but it has certain limitations. You can see here clearly that number of samples on a per function or thread function call is low. I was able to capture some information, but not necessarily at the granularity that I would want to see a profile information. So there are certain trade-offs for the instrumented profiling. There's another option of non-instrumented profiling, which we're going to describe in a separate video. Thanks for watching. Please see our other TimeStorm videos.